Today, we're going to look at a piece of technology that could totally change one of the most basic things we use every single day: heat. It's a clean tech innovation that promises clean, super low-cost heating and cooling for, well, pretty much everything, from farms to the data centers that run our modern world.
But let me ask you this. What if you could generate all the warmth you need for farms, for businesses, even for data centers, by completely skipping the electrical grid? It's a pretty wild question, right? But it's the idea at the very heart of this incredible new technology. Now, to really get why this is such a game changer, we first need to talk about the massive and often hidden energy cost of just heating and cooling things. For a lot of key industries, it is their single biggest expense. No joke.
Okay, for example, think about commercial greenhouses. In a lot of climates, heating isn't just some line item on a utility bill. It can be up to 70% of their total energy consumption. That is a huge, huge burden on our food supply chain.
And it's not just about staying warm. The exact same problem exists for cooling. Take the data centers that power our entire digital world. A staggering 40% of all the electricity they use goes directly into one thing: keeping their servers from melting.
So you might be thinking, why haven't these industries just switched to cleaner options? Well, it's not that simple. They're up against some major hurdles. We're talking super high upfront costs for new gear, the headache of trying to integrate it with old systems, and a deep, deep reliance on a stable electrical grid that, frankly, isn't always there, especially out in rural areas. So faced with all these challenges, a startup called Wind Heater decided to just throw out the old playbook entirely. Instead of trying to make the old systems a tiny bit more efficient, they asked a much bigger question. What if we could generate heat in a completely new way? And the secret sauce here is something called direct energy conversion. Think about it like this. Instead of using wind to make electricity, which then powers a heater, they use the raw kinetic energy from a turbine to directly shake up particles using a powerful magnetic field. All that magnetic resistance creates friction, which creates heat. So motion becomes warmth. Simple as that. No electricity needed in between. And when you see it side by side, the difference is just dramatic. The old way is this long, inefficient journey. A turbine makes electricity, that electricity travels down a cable, it finally gets to a heating element, and you lose energy at every single step. Wind Heater's path is just beautifully simple. The turbine spins, and that motion makes heat, directly. It's a brilliant shortcut that just cuts out all the waste.
So, that's the big idea. But how does this thing actually work out in the real world? Let's break down the mechanics of the Wind Heater system itself.
It's really this elegant three-step process. First, you've got a turbine that captures kinetic energy from wind or even water. Second, that spinning force powers the magnetic heating unit, turning that motion directly into thermal energy. And third, and this is clever, any extra heat gets stored in insulated tanks or these things called sand batteries. Yeah, they're basically giant insulated silos of sand that can hold on to heat for days, making sure you've got warmth even when the wind isn't blowing. And listen, this isn't just some idea on a whiteboard. This team has moved incredibly fast. They went from their first model in 2019 to a fully functional MVP by 2024, and then they launched a successful real-world pilot in early 2025.
But you know, behind all the technology and the business deals, there's a really powerful human mission. The founder, Majid Elahi, has said that his motivation, his driving force since he was just a teenager, has been this one simple idea: hoping to free the Earth from pollution.
A powerful mission is fantastic, but for this thing to really take over the world, the numbers have to work. And when you look at the business case for Wind Heater, well, the economic argument is every bit as compelling as the environmental one.
And this chart just lays it out perfectly. Over a 25-year period for a greenhouse, right? Heating with solar panels could cost you over 900 euros per square meter. Natural gas is almost 300, and the wind heater, 34 euros. Just 34. I mean, the savings are just on another level. It's staggering.
To put it another way, what we're looking at here is up to a 90% reduction in energy costs compared to the old systems. This isn't some small incremental improvement. This is a complete upending of the entire cost structure for industrial heating.
So when you have that kind of an economic advantage, you start to realize the potential impact here goes way, way beyond just one industry. A technology like this could fundamentally reshape our entire energy landscape. And here is where the story takes another fascinating turn. The team realized their technology could basically work in reverse. So now, they've evolved the system to provide grid-free, direct-drive cooling. This is a potential revolution for those super energy-hungry data centers we were talking about earlier. I mean, the potential uses are just vast. We're talking agriculture, food and beverage plants, data centers, of course, but also public buildings like schools and all kinds of small and medium-sized businesses. All of them need affordable, reliable, and now clean thermal control.
And that leads us to one final, really provocative thought. If you can suddenly slash heating costs by 90%, you can now grow food locally in colder climates that were just never economical before. So, could a simple device that makes heat directly from motion actually shift food production closer to all of us, literally redrawing the very map of global agriculture? It's a pretty powerful question to think about.